Hello everyone. So let us start solving a few problems from some standard books in physics from a topic called kinematics. So let us start with the first problem. So in this problem, I'll just give the description of the problem. I won't be copying the exact text of the problem. Okay. So let us start with the first problem. So in this problem, it has been mentioned that there are two particles. Okay, P1 and P2. They are moving perpendicular to each other, and apparently they are supposed to, their paths are supposed to cross each other. So the first particle is moving, let's say, with a velocity of v1, okay, and the second particle is moving with a velocity of v2, and their paths are supposed to cross at a point of o. Okay, so their intersection point is o. So initially, when they started moving, the distance of the particles from point O was L1 and L2 respectively. Okay, and we just need to find out the time at which the distances between the two particles is going to be minimum in their in their trajectories. So, and we also need to find out the minimum distance between the 2 points. All right, so at any time t, okay, so let's say this is time t equal to 0. At any time t, let's say the distance of particle p1 from o is going to be, let's say, y1, okay, and the distance of particle p2 from o is going to be, let's say, y2. So this is at time equal to t. Okay, so we can write down y1 as L1 minus v1 into t, right, and y2 can be written as L2 minus v2 into t. Now at any time t, the distance between p1 and p2 will be equal to square root of y1 square plus y2 square, basic Pythagoras theorem, bro. Okay, so this is essentially the distance, right, between p1 and p2 at any time t. So if I put in the value of y1 and y2 in this equation, I'll get p1 p2 as root over L1 minus v1t whole square plus L2 minus v2t whole square. Alright, if I square on both the sides of this equation, I'll get p1 p2 modulus whole square equal to L1 minus v1, L1 minus v1 t whole square plus L2 minus v2 t whole square. So for minimum distance, my derivative of p1 p2, that is the distance between 2 points with respect to time, should be equal to 0, right? So for minimum distance, between p1 p2, that is p1 p2, dp1 p2 by dt is equal to 0. Okay, so let us differentiate this equation, okay, with respect to time t. Okay, so we'll get 2 modulus of p1 p2 into dp1 p2 upon dt equal to times L1 minus V1t into minus V1, okay, plus 2 times L2 minus V2t into minus V2, okay. For minimum distance, dp1 p2 upon dt should be equal to 0, which means V1 into L1 minus V1t plus V2 into, sorry, let me write it more clearly, plus V2 into L2 minus V2t should be equal to 0, or I can write t into V1 square plus V2 square should be equal to V1 L1 plus V2 L2. Alright, so we get the time at which the distance between P1 and P2 would be minimum as V1 L1 plus V2 L2 divided by V1 square plus V2 square. Alright, now we need to find out the minimum distance between P1 and P2, which is the distance between P1 and P2 at this particular time. Alright, so basically we need to put in the value of t in this expression, right? So if I put in the value of t in that expression, I'll get mod of P1 P2 as root over L1 minus V1 into t, that is V1 L1 plus V2 L2 divided by V1 square plus V2 square, okay, whole square of this plus L2 minus V2 into same time t, okay, V2 into V1 L1 plus V2 L2 divided by V1 square plus V2 square, okay. We need to close the bracket, square of this and this entire thing to the power 1 by 2. Alright, now let us try to solve this expression. We'll get L1 V1 square plus V2 square minus L1 V1 square minus V1 V2 L2 square of this, alright, plus L2 V1 square plus L2 V2 square minus L1 V1 V2 minus L2 V2 square, alright, and square of this entire thing's square root, okay, and I can take out V1 square plus V2 square out of the entire expression, because I see a square of V1 square plus V2 square out here as well and out here as well, and I need to take a square root of the entire thing. So I can divide this entire thing by V1 square by V2 square, alright. So this is what I need to solve. Okay, so this turns out to be, let me just cancel out a few things. This will turn out to be L1 V2 square. I see L1 V1 square getting cancelled with this. Okay, minus V1 V2 L2 entire square of this, plus I see L2 V2 square getting cancelled. Okay, this and this gets cancelled, this and this gets cancelled. Okay, so I get L2 V1 square minus L1 V1 V2 whole square. Alright, and the square root of the entire thing divided by V1 square plus V2 square. Alright, this is mostly, just solving some equation, nothing else. So if I expand this entire thing, I'll get L1 square V2 to the power 4 plus V1 square V2 square L2 square minus 2 times L1 L2 into V1 V2 cube plus, if I square this part, I'll get L2 V1 to the power 4 plus L1 square V1 square V2 square minus 2 times L1 L2 V2 V1 whole cube, square root of the entire thing divided by, let me write it this way, V1 square plus V2 square. This is equal to P1 P2 modulus. Alright, now let me try and solve for this part. Let me simplify this part. So I'll get 1 by V1 square plus V2 square into square root of, let me simplify this thing. If I club this and this together, I'll get minus 2 L1 L2 V1 V2 V1 square plus V2 square. Okay, so these two terms have been clubbed together, and if I try and club L1s and L2s together, let's see what happens. Plus L1 square V2 square into, I can take out common, I can take out L1 square V2 square as common from this and this, right? So what remains is V1 square plus V2 square, and similarly from this and this, I can take out L2 square V1 square as common, right? L2 square, sorry, this would be L2 square, yeah, L2 square V1 square V1 square plus V2 square. Okay, and the root of the entire thing. So it means effectively that V1 square V2 square, sorry, V1 square plus V2 square is common in all the three terms. We can take this out. Okay, so effectively what I'll get is root over V1 square plus V2 square divided by V1 square plus V2 square into square root of the entire remaining term, that is L2 square V1 square plus L1 square V2 square minus 2 times L1 L2 V1 V2 to the power 1 by 2. So effectively my P1 P2 turns out to be L2 V1 minus L1 V2 whole square, because this term is exactly this, right, whole square, and this to the power 1 by 2 divided by, if I cancel out 1 by 2 from these two terms, I'll get root over v1 square plus v2 square as the denominator. So this effectively turns out to be modulus of L2 v1 minus L1 v2. Let me write it more clearly. L1 v2 divided by root over v1 square plus v2 square. Alright, this is what my answer is. Let me write it down more clearly. P1 P2 minimum is equal to modulus of L2 v1 minus L1 v2 divided by root over v1 square plus v2 square. Okay, so this is my answer. Alright, let us solve another problem. So in this problem there are a few things mentioned. It's been mentioned that there is a person which is located at point A on a highway. So let me draw the highway first. This is my highway, and my person is initially at point A, and this is point D, and this is my highway. So on the highway the person A moves with a velocity of v, okay, but the person actually needs to travel to a point P which is at a distance of L perpendicularly to the highway. Okay, so such that this point of intersection between this L and this highway is D. Okay, perpendicular to the highway, but this perpendicular thing is perpendicular to the highway, but at a distance of L from the point D. Alright, so this is the point wherein this person is supposed to reach. Let's call this point as point B. So he's expected to move out of the path on the highway and cross over a field. So this essentially is the field. This area is the field, and it's been mentioned that his velocity on the field is eta times smaller than the velocity on the highway. Alright, so let's say he had to switch from the highway to the field at a distance, let's say x from point D. Okay, so let's say this is point C, wherein he switched from the highway to the field to reach point B. Alright, so we essentially need to find out the distance at which the switching happens. Alright, so let's say at time t equal to 0, the distance between the person and the point D was, let's say, capital L. Okay, so the total distance that he would have to travel is L minus x, okay, plus root over x square plus L square. Alright. The time which he would take to travel between point A to point C would be L minus x divided by V. Okay. And the time that the person would take to move from point C to point B would be root over x square plus L square divided by the speed of the person on the field, that is V upon eta. Alright. So if I divide this by V upon eta, eta will go up and V will be in the denominator, and this is the total time. Okay. So this is the equation which we get of t, that is the total time which the person takes to move from point A to point B, versus the distance x, that is the distance at which he switches from the highway to the field, okay, with respect to point D. Alright. So in order to minimize the time taken, we just need to differentiate time with respect to x, and the value of the differential should be equal to 0. So essentially, for minimum time t dt upon dx should be equal to 0. So if we divide this equation, if we differentiate this equation with respect to x, we'll get dt upon dx equal to minus 1 by v plus eta by v into 1 by 2 x square plus L square, x square plus L square to the power 1 by 2, and then we need to differentiate x square with respect to x, so that will give me 2x. So I get this 2 cancelled. Alright. So this should be equal to 0, right, for minimum t. So essentially what I get is, I can cancel off this v as well, right, because if I move it on the RHS, like v gets multiplied by 0 and we can cancel that off. So we get eta times x divided by x square plus L square to the power 1 by 2 equal to 1. This implies eta square x square is equal to x square plus L square. This implies x square equal to L square by eta square minus 1. So that gives me the value of x as L by root over eta square minus 1. Therefore, the distance from point D, right? The distance from point D at which the person should switch his path is x equal to L by root over eta square minus 1. So for now, let us solve just these two problems. We'll come up with more difficult problems in the next session. Alright, bye.